can still see this stuff. Okay, so what I've got here is just a big whiteboard, and I've got a tablet, and then I can write on the tablet. It's similar to how I used to teach. They say when you are starting something new, you go back to what you already know. And what I know is teaching. I can also... Okay, I don't think the Teams chat works yet because Teams is they move this over here. Teams is fun. So let me post this here. Maybe some of you can see that if you have access to Teams. If not, I'll also throw it into a thread on Slack. And I'll revise that later so it looks nicer. Okay. All right. So are you guys familiar with the Van Thunen model? I'll write it out if you want. Or Von.
Van Thunen, yeah.
Have you guys worked at this model before? Oops, that is off the screen. This type of model? CWA, maybe.
I sort of know conceptually what it does, but I've never really worked with it extensively.
Cool. That means this is going to be new for at least 2 of you, which is cool. Okay, so I already have this as a GitHub repository, but I'm not going to use that quite yet. We're just sort of going to build it and then see what happens. Let's see here. Let me get my cheat sheet open so I don't look totally dumb. So here's the model assumptions. So there's a city center. Obviously, that's going to be that bad boy right there. Everybody lives in the city center, and they commute out to work. Concentric circular fields. So there's the first one. In fact, you know what? I won't even do that. This one is just like R1 and then R2, so on and so forth. There's 3 crops: beans, wheat, and corn. These crops have weight so that it affects transportation costs from origin to destination. There's landowners and laborers. Again, they both live in the city. Landowners endow land, laborers endow labor. Nothing revolutionary. The agents each demand 1 unit of the crop. So they'll each want 1 corn, 1 beans, 1 wheat. We'll take labor prices numeraire just to normalize things. And then crops have an initial land share. So basically, like you partition the fields into 3 parts, and you'll have like corn, beans, and wheat. Cool. And what we want to do is we want to model this so that we can see what the prices of goods are, what the price people are going to pay for goods in the city center. That's our goal. So we want to goal model to find good prices. Anybody? So I think I think about this a little bit differently than you guys because I'm a mathematician. So I'll sort of tell you guys how I think about this, and then I want to hear how you think about this. So the way I've been starting thinking about these things. So I'm going to scroll down. I'll go right down here. The first thing I do is I try to think about what the sectors are. In other words, what's being produced. And the way I see it, there are 2. There's transportation, and then there's the actual agriculture, like the crops and good. Agriculture. Sorry, I can't spell and talk at the same time. I see that there's kind of 2, right? You got to get the goods to market, and you got to actually grow the goods. Oh, Google, you're listening, and I don't need you to. Sorry, my phone decided to transcribe everything I was just saying. Transportation, that's going to depend. That's going to depend on both the region and the good, because you start in the region, you got to take the good. So far, nothing too terrible, right? Okay, cool. Same with agriculture, region Good. Cool. So this is the first thing that I do. And then from here, this is where I start to get a little confused. Finding the sectors is actually quite hard too. It can be, for me anyway. But what I do is I'm going to try to find the flows. I'm going to put R and G. Okay. So this is the part where I actually define the model. So what's the result of transportation? Like, what does transportation output? And
Well, you went on activity level, right? You went on, your flow is your activity level of the transportation sector.
in a way, yeah. Yeah.
Okay, I mean, something like passenger kilometers, right?
Yeah, I think that'll actually be one of the inputs. I think the output, all they're going to do is they're going to drop off the goods in the city center, right? So they're going to take their goods and they're going to sell them in the city center.
Mhm.
So the output is just going to be the price of the good. And then we'll just say they sell one. This is just sort of this is a reference quantity. It's like the initial quantity. In this case, we don't have any data, so we don't actually know how much they're selling. So we're just going to say they sell one, and that'll affect the price. So they just take their goods and they sell them at the market. And the inputs are what's going into it. So they have to buy their goods, which is, I called it region price because I am wholeheartedly original. Oops, and that's going to depend on, that does not work as an eraser. There it is. That's going to depend on both the region and the good. It's a clever value. Nope. Just one. If we had data, that would be an actual number. We'll just say it's one. And all of these numbers are really actually kind of arbitrary. Like because we're doing a calibrated share model, these initialize to 1. So all commodities are going to initialize to value 1. And these are just talking about like the total value of those goods that are being sold. So we're just saying it's 1 for now. Everything will adjust. There's one more input that I see. There's labor. Labor. Oops. Labor price, the price of labor. And this one's a little bit trickier for the quantity because we want this to depend on both the weight of the good. I've lost it. Right here. The weight of the good and how far they actually have to travel. Right? Because if they start here and they go into the city center, that should be cheaper than starting here and going to the city center. Does that have a logic to it? So what I'm just going to call this is it's going to be the distance of the region times the weight of the good. That seem reasonable? And again, this is going to be a slightly different way to think about this because I've talked about this with Tom in the past. And it seems like Tom starts with the completed model, and that's the end of his process. Okay. Just thinking, I just have my cheat sheet. Okay, cool. So this first one's kind of hard, right? Because there's no sort of context. The next one will probably be easier. Agriculture. Okay. So the way I think about this one is it's within the sector. So it's right here. So what the agriculture is outputting is it's the price of the crop in the region. So it's going to be region price of the good, just say that's 1 for now. Let's see here. There's also land value. Oh, did I call it land price? Nope, call it land value. All right. Just want to make sure I have the notation the same, so that when I write the model, it looks right. Yeah, sorry.
Go ahead. Sorry.
Okay. And right, so there's land value. I'm going to leave the quantity off for the moment because we're also going to have labor. People have to work. In theory, you could replace this with a nest where it's labor and like machines. That'd be kind of interesting. And the quantity that we give this is the land share. So I said initially, I go up here. I've lost it. Did I not? Oh, right here. Crops have an initial land share. It's the last one. I did forget it, and then I added it last. So in each region, each good has a specific land share that it's going to be occupying, like the preferred. There's different fertilities and stuff like that, so things grow better. Just initially, like in the code, it's all random because it's more about the model. Okay, so that's what I make this value. And the question becomes, what's the number on labor? And I'm just going to do sort of the cheap thing. Land share of RG. So this is kind of cheap because, does this have a laser pointer? Maybe. I can't see it. This is kind of cheap because essentially what we're doing with this guy, we know that this value and this value have to match to be that value. Inputs have to equal outputs in a balanced model. So seems like a fair thing to do, right? Just make it 1 minus what it has to be. So that way they add up. Plus it kind of makes sense. What's giving value to the land? Well, the land value and what's ever left over. All right. So what I'm implicitly doing here is I'm trying to figure out what the commodities are. And I have it correct here because I've thought about this, but initially developing the model, I don't know exactly what these are. If I have the data, then I do. But if I don't, I can just sort of identify them as I go along. I think in the past, Tom would go to commodities now, but I'm going to go to consumers. Because there's going to be 2 consumers, landowners and laborers. There's only 1 region, so they're both representative of their group. And then I'm going to do the exact same thing. I'm pointing at the screen, which is not useful. I'm going to do the exact same thing here. I'm going to do the exact same thing for consumers that I did for sectors. Do you guys think of sectors and consumers as being similar?
Actually, no, Mitch. So what's confusing me is I think you're mixing up the production functions with the dual cost functions here. And production functions have the quantities, and the cost functions are also called price equations. And so cost functions are just prices. That's all. And then production functions are quantities, but production functions never appear in a CGE model. You're always working with derivatives of the cost function.
Yeah.
But the way I try to do this is to set up a small social accounting matrix to start out with, and then things kind of flow pretty easily into these diagrams of inputs to outputs.
Yeah, that's very interesting. I should really have one of you guys, if you want to do that someday. But I think it's kind of the same thing, right? Because any tree can be represented by a matrix, right? So what I'm doing here is kind of constructing that social accounting matrix, right? Because you have, how's it go? It goes sectors. Oops, I can't spell. Sectors and then commodities, or yeah. So how would it go, right? It would go transportation, and it would go price, and then it would be, our outputs positive or negative? I think they're positive, right? Oops, what am I writing there? Region price. This would be -1. Labor price would be negative distance times weight. Oops. Right? Does that, I should ask, does that satisfy like what you think of as a social accounting matrix?
Well, the social accounting matrix only has values in it, benchmark values, and so that's.
This would be, this should be a value.
And then most of the prices
are.
are 1, so.
Yep.
Then
That's where this breaks down a little bit. Yeah, that's where, because this isn't coming from a balanced model. If we actually had data, it would come from a balanced model. Like this would actually balance out. But that d times is a number because the weights will be given and the distances we know. I'm just putting it as a formula because I don't want to figure out the distances right now. So in fact, I'll raise this one to you right now. What I don't like about the social accounting matrix, let's say I had, so a T, I have an output of P, I have another output of like, so here I have R, P, and then here I might have like labor price and capital price. I usually use a K, don't you? Right. And here I would have a nest of some sort. In the social accounting matrix, this would look like this. And the value is here, 0.5, right? Here, I'll make the numbers actually numbers because it's easier. We'll make this be 0.5, 0.25, and this 1.25. Okay. Here's what I don't like about the social accounting matrix framework. How, as an outside observer, how do I know that these two things are going to be nested in that T block?
You don't know from that.
That's why I don't like it. Yeah, because there's a relationship between those two things, right? Like you can transition between those two. That's why I sort of gravitate towards the trees, because the tree makes that evident. I think the way that he does, because of course I do. What's the word for it? Different. LP, KP. I think he uses like a thing there with sigma, whatever the sigma value is. I just do the same thing. I just make it be a node. Like I would say sigma equals 2, just to denote the elasticity.
Yeah, so Mitch, to actually define the nests, you would need to create another product. Like when you have got labor and capital nested in the bottom right, where they come together, you'd have to define another product, call it, VA for value added or something. And then you would have a production sector in the social economy matrix that's called VA. And then the inputs of that would be just capital and labor. And then your first column would have value added as an input.
Yep.
Yeah. So, I mean, you can split apart the social economy matrix, but even then, it doesn't tell you the substitution elasticities. Those have to be specified somewhere else. Yeah.
Yeah, I believe those are hard to find too. Right, like knowing exact values.
Yeah, we normally don't know them.
Yeah, here's how that would look in a tree structure. Oops, exactly what you were just talking about, LP, KP. So basically what I would do is this just becomes a new tree. I call it VA. Let me make this looks nicer. So essentially I get two trees out of the one tree. So you just like take this node and rip it out. And then I call that FP for fake P, fake price, or price of labor, it could be. Or total price of like capital value added. So that'd be the same. That's exactly what Ron is talking about. Making like a second type of good and then having more things, I believe.
Yeah, that's exactly it. Yeah.
Okay, cool. Yeah, part of this is me understanding you guys as well, because it's non-trivial. Okay, can I move this? Oh, I can. Okay. I'm gonna move that up there for now. I'm gonna keep it in there though. And I'll go back and annotate that in a bit after the meeting. Yeah, so I should emphasize that when I look at this, I see the social account, like it's the same to me. Social accounting matrix, trees, graphs, they're all the same. I just like to know the elasticities. I like to know the nesting structure. At the end, I'll show you the GTAP model as well, because I don't think that fits well into a into a social accounting matrix. Consumers, let's see, I got landowners. Oops, I'm still landowners and laborers. Hey, all right, that's on the screen. Oh, also, if I'm ever writing and you don't see on the screen, just yell at me, because then I've forgotten to move the screen. I would like to say that I never did that well teaching. But I can't even lie about that. I did that all the time. Okay.
So Mitch, yeah, before
Yeah.
we go on, you mentioned fitting the GTAP model into social accounting matrix. Now the farm model, which I use, starts out with the GTAP data set, but then I create all of these little sort of new production functions to deal with
Yep.
nesting and so on. And so my social accounting matrix ends up being very sparse.
Yep, I believe it.
So I never actually look at it.
I believe you.
I never print it out or
believe
look at it. Yeah.
you. Here, let me. Okay, I gotta go here. I'll do a spoiler right now. I'm gonna post these two. There we go. Okay, why did you decide? There it is. This is the Y production block for the GTAP model. And I put a lot of notes on. This is what my notes would look like when I was teaching, is just the fastest way for me to do this. Y production block, I put this in later. Only thing it's outputting is goods, right? Automatic, like this is really complicated. This right here is what I want to point out. Because like Ron says, you have nests for every good. So this I is an index, and it creates a nest for every single good. Because for every single good, you can either have it domestic or imported. And there's some transformation between those two. And in MPSGE syntax, it looks like this. Like it's very simple because I can encode that nesting very succinctly. I'll show off that model I'll show off that model a little bit today, and I'll probably do it on Thursday as well in more detail, because there's a lot of really cool things going on with this model. And on Thursday, we're going to do the MPSGE monthly, I call it. So once a month, we'll go deep dive into MPSGE, try to understand what exactly is happening. But yeah, to exactly Ron's point, that's why I like the trees. Because you can just, it's a 1,000-yard view. It's also very complicated. Yeah,
So
go ahead.
Mitch, what time on Thursday is the meeting?
Yeah, I'll probably do it. Go for it, Siwa.
Yeah, did you send us an invite for that yet, or?
I haven't yet. I was going to do it right after this meeting because I was going to talk to the people here.
Okay.
I have it planned for 11 a.m. If that doesn't work, I can shift the time.
Like basically this time, yeah.
Yeah, 11 a.m. Does that work? Thumbs up, thumbs down.
For me, it works this week.
Okay,
That's
and
a
it's
month. It's this week.
okay, cool. I'll send out an email about that, and I'll write a note to myself. Yeah, because I'd really like to like this is such a slick little thing, and the MPSGE model looks exactly like this. To me, Eli's probably like, it doesn't look like anything like that. But to me, it really does. Okay, there's all the answers. Okay, I'll do this last part quick so that I can actually do the Julia part, because I think that'll be more interesting. Okay. Landowners, endowments go on top because they're outputting it. I view endowments as outputs. They're outputting land value. And that depends on the region. And the, where is it? Land is the land. So it's just the area of R. And demands are inputs. The only thing the demand is food, right? Price of the good, and they're demanding 1 unit of it. Again, if this were calibrated, that would be a better number. Laborers output labor price. Oops, I got to make sure that is that what I called it? Yep. Labor price. I'm just going to have that value be L. That'll be a model parameter. And that way I can change it later. And they want the price. They want to eat. Cool. Everything that I have at the end as a leaf, everything that's a leaf, I should ask. If I say words from that you don't know, like math, like leaf to me is a math word. Do you guys know what I mean by leaf? It's just the end. Yeah, just the end of the tree.
Branch.
Yep. Okay, cool. Commodities. All the leaves are the commodities. Let's see here. I got the price of goods. I've got the region price. R comma G. Labor price. It's only one labor price because there's only one labor. And what else is there? Land value. And that is just given by the region. Okay, I think I hit them all. Using these trees, or using the trees, I'll say this really quick so that we can get to Julia, which is going to be fun. What you really want to do is make sure that this is an output that's a sink. Every output needs a corresponding input. So if you ever have something, like if price wasn't represented as an input anywhere, then your model's not going to be balanced and you're going to get errors. So everything that's an output needs to be an input somewhere. And if your model is balanced, then those numbers better match up. Like 1 plus 1 should really be a 2 if we're talking about a balanced model. Okay, but we're not balanced right now. We're just we're playing fast and loose. Okay. Okay. Tablets. Move this over here. Okay. So all I did is I opened VS Code and I just opened a folder. So I click this button right there, open a workspace, and I just picked an empty folder. Cool. Eli, feel free to tell me when I do things wrong.
Oh, this is going to be great. I'm interested to see your workflow.
Okay, so all I did is I opened a terminal. On my keyboard, that's control and then like the tilde. The terminal, it opens and closes it. I've also moved it to be on the right because I've got a wide monitor. I'm just going to do that now. I make sure that I'm in the directory that I want to be in. I start Julia. Hit the right bracket to open the package manager, and I type activate dot. This tells me that I'm in my base package, which I don't want to be in. This is putting me in, it's activating the Julia example folder that I have. So now I can type add. I'm going to need MPSGE.
I don't know how much time you have, but I don't know if there's questions about that because all that stuff was super confusing.
Sorry, say that again.
Oh, sorry, I wanted to. I mean, for me, that stuff was really confusing, and we went pretty quick. I don't know if people had questions or sounds good. The environment stuff's confusing.
Yep. And I'll talk about more about environments in the future.
Yeah.
Because
Just matter if anyone did, I think just know the answers and I suppose just have to say.
yeah. I should say, notice right here, I now have a project.2ml and a manifest. The manifest is something that you can share. It will absolutely lock down all the packages that you have. If you're making a package, you'd want to exclude that because the Julia will just recreate it for you. And there's a lot of stuff in here you can do too, like set package versions and stuff. But cool. I'm going to open the command palette, Control-Shift-P, create a new Julia file. Oh, it's right there. I'm going to just call this main.jl because I'm on original. I'm going to check right here. The Julia environment that I have active. I'm just going to make sure that it's the folder that I want. So when I type using MPSGE, as I enter to run it, it'll open a terminal. And now these two things are going to be linked. So anything I type in here, I can hit Shift-Enter to run it over here. Come on. You know you want to. Now I got to do a couple things. Five. Okay, cool. I'm just going to start with 5 regions. I just did a little fancy magic there just to make 5 regions. The command symbol will turn something into a symbol, and the dot means make the symbol for every element of this list. What else am I going to need? I got my thing here. I'm going to need a distance. Okay, I'm going to do this the stupid way. Problem solved. I'm going to need an area for each one. And what is this going to be? Pi r squared, right? Pi times, oh, thank you, AI. If you are working as an individual and not for the US government, I recommend Copilot because it will probably just figure out what you're trying to type.
Some of us already had Copilot when at the ERS. I mean, I had Copilot on my personal computer.
We won't tell. Beans, wheat. Okay, named array, I got to remember the syntax here. We'll go 0.1, 0.4, and 0.5. Is that the syntax I want? I also want this to be a named array. So you might be wondering what a named array is. And it's array. What are you doing? So basically now I can use area and I can use my region symbol names because the named array has the index given by regions. And I should really do this for distance too. Is this the only way to put indices like that on things like this? No, this is just one of the packages. Many other ways to do it. What else do I need? Do I have land share? Nope. I think this one is on both regions and goods. Point 2, 0.3, 5. I think I'm doing this backwards. Yeah, what did I do? Oh, I didn't end the name array. Cool. So I just let AI fill these in. Because why not? It just did it. They all add to 1 across the way. Good enough. Those numbers don't really matter. Now we just check if I need anything else. I got the area, I got the weight, I got the distance. We'll just see what happens. I get to make an MPSGE model. Okay. Now we actually get to start out with my data. So far, it's an empty model. M, L. Oops, I got to initialize it, right? Let's initialize to 3000. Labor endowment. Cool. So all I'm doing is making a parameter called L, and I gave it the description labor endowment. Okay. Now I got to do the sectors. Notice I made one parameter, so I used the singular parameter. An S. And what do I want? Transportation. The regions. Good equals goods. And agriculture. Cool. People are going to ask, why do you do this? And I don't need to. Oh, no, we go for it.
Yeah, I haven't had the chance to play around with this package. I play around with jump, but sectors is not a macro jump, isn't it?
Nope, this is a MPSG thing.
Okay.
Yeah, so what this is doing is this is in the background making jump variables.
I see.
Yep. Yeah, the reason that I'm doing region equals regions, this little index is going to be unique. You can't repeat this throughout. Regions, however, could be, I mean, I could have another regions here, right? Like it could be indexed on regions twice. That's totally fine. That's why it's grabbing this one. So it can just tell me an index there. If I don't put anything, and I do M, then it's a made up variable because it needs a name for it. So it just makes it up. And then I have to, oh. So I always put commodities next because that's what Tom always did. Doesn't hurt anything, but I do have to scroll. Oops, price of good equals goods. I could add descriptions to these as well. That's making it better. Labor price and land value. Consumers. Let's see here. landowner, labor. Cool. And then if I go to my terminal, Control L just clears it. And you can see I have everything allocated. And now I get to make the production functions. So I've heard a lot of people, and I'm sure Ron, production. Yeah, production. Because it should be like cost or like something like that. Because they are cost functions. Ron's 100% totally right. They're cost functions. Production, because that's what Tom called them way back in the day. So what I did here is I did it wrong. This transportation, I'm just looking at the tree that we made. R equals regions, G equals goods. So I've used R and G here. There we go. Just because it's going to be less to type later. And then I have an output. And the output is P of G, quantity is 1, and it's nested under T. It's an output. So this is right here is defining my nesting structure. Transformation, substitution. They don't have to be T and S. They can be anything. T and S is just for, that's what they've always been. The difference, if you use MPSGE and GAMS, like I'm sure Ron does, you have to be explicit about the names here. And you have to be explicit about where it's going there. That was an intentional design decision because I don't like it when things are hidden. Region price RG1, and that is under S. Let's see, we got labor price. Oh, and this one's more interesting. This was the distance of R times the weight of G is nested under S. P not to oh, because it's price, isn't it? Then we have to wait a second. The first time you run a production block, the first time you run any Julia code, it takes longer. And then it prints them all out. So like this is one of them. And I'll show you extracting that in a second. I'll just keep typing the model. Okay. I doubt this is going to be right. First things first, I said the elasticity here was 1. This one is correct. This one is not. This one is not. In fact, this one's very wrong. What is this one? Oh, it's totally wrong. Okay. Labor price is 1 minus land share of R. And this one is just land share. Did I not? Oh, because it has a G. I'm guessing everybody saw that and they just, there it is. Cool. 2 demands. Again. So demands do not yet have an elasticity structure. Eli and I are yelling about that back and forth. Eli's very pro.
Well, no, maybe you take a quick that because basically I'm advocating somewhat strongly for nested demands so that we can have an inbuilt function to have like that demand utility calculation, like a final consumer utility calculation within the package with nesting in it. So we can have a nested utility and actually calculate like equivalent variation rules and
Yeah, Eli is very pro and I am very medium. So he's probably going to win.
sure.
And I'm almost done typing.
So right now, in GAMS, MPS, no, this is 10 like sort it out for another time.
Okay. Cool. So I got everything typed in, a couple things noticed here. And this has an index on it. And then that index gets used. So if I look at the demand of landowners, hey, that actually worked. So there isn't actually just one demand. I exactly mixed those up, haven't I? Son of a, okay. Did anybody notice that I did that? There's one for each price, and then they're endowing each of the lands with the whatever the area is. Cool. I also realized I probably have these areas wrong, but I have them correct in the actual code. Because the area, I'm doing the whole circle, not just the annulus. So it's correct in the actual code, and it doesn't matter so much here. Okay. So at this point, I should stop for a second and say, see how you go from here to here, or here to here? Like transportation, I've got the two elasticities, outputs, inputs. So I've just sort of typed it exactly how the tree looks. Forgot that endowments are outputs, and screwed that up. But yeah, literally all I have to do now is solve. And then we have to wait for a second because the first time that you run something in Julia, it takes a while. Oh, and I've forgotten to do something, of course. Oh, it actually worked. Oh my goodness. And there we go. So this is the actual balance model. We start with something that wasn't balanced. So that's why I didn't like run a cumulative iteration limit equals 0. But here you can see all of the values for all of the things. So if I wanted to look at the land value, I think I need to do, oh no, I can do this. There's all the land values. If I made more regions, this would give me an error, just FYI. I account for this in the actual model. But this would give me an error because the land values eventually go to 0, and then you start dividing by 0. So one of the things you have to do, I'm just going to move this one over. So here's the actual package. Here's the actual model that I wrote. As you can see, it looks identical, except the distances are correct. Because it should be big radius minus little radius. I put in a couple more endowments, or parameters, but the model is the same. And I also put a lower bound on land price of 1 times 10 to the minus 6. That just stops those from going to 0. And then, yeah, it's literally the same model. And if I come over here, I also fixed the labor price to be 1. Solves great. And I can like look at this price. And then I have a listing file. What is this? This is, okay, what is PL? Here it is. Hey, the numbers are the same. Corn, wheat, beans. It's backwards, corn, beans, wheat. But the numbers are the same between GAMS and MPSGE in Julia. I always want to show that off because I'm not lying to anybody. I don't want to lie to anybody. But the benefit here, the major benefit of using Julia, I'm still running my code So I can do things like cost function of transport R1 corn, transportation. There's my cost function. Let me move it up to the top of the screen. So that's the actual cost function that's going into the model. There's a reason that I picked this one, and it's because the cost functions are really simple. I could also do the revenue. I think that works. Yep. Cool. Elasticity 0, they're very simple.
You can broadcast cost function.
Sorry, say it again.
You can get the cost function for all the different regions.
Oh, yeah.
You do that?
Julia has a, I'll do cost functions. Julia has a nice thing. The dot is a broadcast operation.
And you put the,
So there they are for every single one.
I mean, I don't know why you would do that, but it's just like the broadcast is the rest of it. So.
If you're like, man, I wonder what the zero profit condition is. There it is. That's the actual constraint that's going into the model that's being solved by Jump. Same with market clearance, except now I need a commodity. Do market clearance. Oh, okay, corn. There we go. There it is. That's the actual market clearance condition that's going into the model. So it's much less of a black box.
Income
I can
balance.
also get. Say, were you going to say compensated demand?
Oh my, I was going to say income balance, but yeah, they're all good.
Oh, yeah, you can. Transportation of one, corn, and let's do labor price. Okay. Did that do that? That's interesting. Okay, I'm going to get all of the compensated demands. I think that one is just a number because of yep, they're all just numbers. Cool. Strange. Okay, I'm going to switch to this one. I'm going to look at this GAMS file, and I should stop talking soon because it's almost noon. There's one thing that we're just not going to do. We're not going to implement production blocks, or report blocks. We already did implement production blocks. We're not going to implement reports. So the question becomes, what are these reports? And this is what they are. So this report block is saying, from the Y sector, give me the compensated demands of PL, which is labor price. Except it's not quite that. It's the compensated demand multiplied by the sector activity level. So it's compensated demand. And I'm getting all of them here. I'm putting a ref here just so it knows not to iterate over this, not to broadcast over this. And then I multiplied it by that. These are the numbers that I get. And if I look at here and search for DL, there you go. Corn in region 1. Ooh, okay, there we go. Corn in region 1. Cool, right? So we should probably write a function that just extracts that value, but there it is. And then the last thing that I'll show off, because, I mean, what else are we going to do here? I want this. The other benefit of Julia is that you can make animations really easily. So this is taking the labor endowment from 10,000 to 1 million, and it's just showing what happens to the land value. So as there gets to be more labor, the land value goes up because more people can work. So you get more value out of the land. And just to show it off, I've linked the I've linked the repository that holds all of this stuff. Oops, this, graphs. No. And I'll put this in the Slack as well. This is how I collected my data. I'm just giving it a range of labor endowments, 10,000 to 1,000,000, making a data frame with this function right here. This just extracts the information that I want. I'm going through this quickly because it's not that important. Zoom up just a little bit. The actual animation is here. You can play around with this. So it's got the slider at the bottom. Got update menus, got frames. But it's all integrated into one, so you don't have to export to Excel, which is exactly what Tom does right here. The one-stop shop. Okay, so I should stop because it is exactly noon. I said I would stop at noon.
Mitch, I just want to mention one thing about this nested demand. The way I get around that is if you've got some good that's being demanded by a consumer, and let's say that's grains, and you want that to be a nest of corn, soybeans, and wheat, I just move that nest into the production side of the model.
Yeah. So the thing that I'm interested in, and totally interested in what you think on, is like, if you do that, then you get what you want in terms of the nesting for the actual demand solved, but you can't neatly calculate like the actual utility because they're in two separate blocks.
Honestly,
Whereas,
I don't actually think that's the problem. Sorry, Eli. This is not the right thing. So Eli's right. Yeah, you can't, like you say, you can't easily do a couple things, but where is the one that I want? Here it is.
but in my model, I have like a nested CES utility function and have it as a production block with a single utility good, which is another sort of MPSC thing, and to bring a lot of what I'm saying, that when we got entire consumption and nesting it into one commodity. But if we put it in the demand block, I'm spooky again, then we can just automatically say we know that that's a demand, and that the final demand is, one way of constructing the utility. And then we can sort of build in a function that says, like, what is the relative utility that we get from different self-paying factors and so forth, in a way that you can't do if you're sort of generating your own sort of workarounds with putting aspects or even all of it into a production block.
Yeah. And to build on that, here's what I see. So Ron, what you would do is you would take each of these and make them be a separate like production function, right?
Only the ones that have a nest underneath them.
So I mean, that'd be like M and nest.
So you could have like your top layer of the demand could be just Cobb Douglas or CES. Yep. And then some of those could be nested below that, and then those get moved into the production side. I think you could still calculate welfare.
I think you could. It would be more cumbersome. But if you look here, you're going to get one nest. You're going to get an additional production block here, one here, and then you're going to get I of them. So what you're doing with that is making your model specification be much larger, which is fine, but this GTAP model fits on one page. That's the real benefit. Like you can just look at it and get sort of a bird's eye view. This is how I'm doing that nest, by the way. The code is right there.
I'm looking forward to sort of going over the GTAP and really cool.
Yep. I'll go through that much quicker.
Yeah, so I'm looking forward to that presentation.
Okay. I'll prepare well and do a good job.
And I'll have a much bigger screen. I've got this tiny screen today. I've been like squinting and bouncing. So that's why I was able to help you find the cover.
Yeah, I've got
Yeah.
well, yeah. I don't
There's a
know
lot
how
of
to
demands, right? We want that. That's the, summing up, there's a lot of demand. Consumption
Yeah.
too.
So
I have a big demand for it.
I should warn everybody, I'll just keep talking until somebody says something else, but I'll see what looks like he might.
To access the recordings for these sessions, if you don't have the chat, I mean, will it be? I'm wondering if in my
Yeah, I'm going to. I think I'll put links into Slack, and I
Okay.
will. I have to get the WiNDC website, so it does that as well. Because I like the seminars to have the recordings and like a synopsis and other crap I put on there on the website.
We should look into like making teams work with the chat.
Oh, I tried.
Really not
That's
that
in.
easy.
That's at the organization level, and I don't think they're going to change it for me. And the WiNDC website, I did actually finally get it updated. You can more easily search for model versions. But I would really like this to be a link, which then takes you to a page that just lists them all. Yeah, and that should be pretty easy for me to do tomorrow or later today, like this, like the papers. I just had such a hard time finding things on the old website. It's so hard. All right. Let me hit. I don't know how to stop share. Oh, it's right there. Big button. It says stop share. Check that out. All right.
Great, thanks. So we'll look for the link for the Thursday meeting then. You'll.
Yep. I'll throw that in
Alright.
Slack, Ron. I'll send you an email with some information. Yeah, and I hope to see some people.
I can get the link for Thursday. I mean, we can't use Slack here in the government, but
Okay, I'll get it.
just any other way would be fine. Even,
Yep. I'll figure it out.
Okay. Okay.
Thank you, everyone.
Yeah, thanks for coming.
Thanks, Mitch.
Yep. Stop recording. Stop.